In this section, we find derivatives of y with respect to x using implicit differentiation. Our first problem, we want to use implicit differentiation to find dy dx. Here we assume that y is a function of x. So we're always assuming that y itself is a function of x. So we're going to take the derivative of the entire equation. The derivative of x squared is 2x. The derivative of y squared is 2y. Then we must multiply by dy dx. And the derivative of 1 is 0. So now we get 2y dy dx is equal to minus 2x. And then when we solve for y dy dx, we get minus 2x divided by 2y. And so we can get our answer, and that is dy dx is equal to minus x over y. So our second question, we have x squared minus xy plus y squared is equal to 9. Again, this is our second question. Again, we're trying to find dy dx. So we're going to take the derivative. The derivative of x squared is 2x. Now I'm going to have to use the product rule. So I'm going to have the first x times the derivative of the second. I'm going to use y prime because it's shorter than dy dx. Then we have plus the second, which is y, times the derivative of x, which is 1. Then we're going to take the derivative. We're going to get 2y. We have to multiply by dy dx. That's y prime. And the derivative of 9 is 0. So now we have 2x minus x y prime plus, minus y plus 2y y prime is equal to 0. So we want to take 2y minus x, multiply that by y prime. And then on the other side, we're going to have y minus 2x. So now we get y prime is going to be y minus 2x divided by 2y minus x. And now we have our derivative. So that is the derivative dy dx. In this next problem, we want to find the equation of the tangent line to the folium of Descartes at the point 3/2, 3/2. So the folium of Descartes is this equation right here. And this particular function has an asymptote and this function is as such. So it looks similar to that. It's folium of Descartes. And we want to find the derivative at the point 3/2, 3/2. So we want to use implicit differentiation. So we're going to get 3x squared plus 3y squared. Then we have to multiply by y prime is equal to 3. And now we're going to use the product rule. The first x times the derivative of the second y prime plus the second y times the derivative of the first is just 1. So now we want to put all the y primes on one side. So now we're going to actually, let's divide by 3. Since everything in the equation has a 3, we can divide by 3. So we have x squared plus y squared y prime is equal to x, y prime plus y. And so now we're going to get y squared minus x times y prime is going to equal y minus x squared. So therefore y prime is y minus x squared divided by y squared minus x. So now we need to find this derivative or the slope of the tangent line. So we now need to find our so now we know what our function is, our slope is. So now y prime at the point 3/2 is going to be our m. So m is going to be 3/2 minus 3/2 squared. And that's going to be divided by 3/2 squared minus 3/2. And this is going to equal -1. So now we have slope m is -1, and we have the point 3/2. So we can get the equation of the tangent line, y minus 3/2 is equal to -1, or negative times x minus 3/2. Okay. Next question. We want to find dy dx for x squared is equal to sine y. So take the derivative of the left-hand side, we get 2x. The derivative of sine y is cosine y times dy dx. So therefore we get dy dx is simply 2x over cosine y. Our fifth problem, find all points on the curve y to the fourth plus y, x to the fourth plus y to the fourth plus 2 is equal to 4xy cubed. In order to solve this problem, we want to find dy dx, and we want the tangent line to be horizontal. When the tangent line is horizontal, for us, that just simply means that the slope is 0. So that's what we're going to do. So we get 4x cubed plus 4y cubed dy dx. Derivative of 2 is 0, is equal to 4. We're going to take the product rule. So that's first x times the derivative of the second is 3y squared dy dx plus y cubed times the derivative of x is 1. Now, once again, we can see that every term has a 4. So we're going to divide out the 4. And we're going to get y cubed minus 3xy squared is going to equal y cubed minus x cubed. So there, we're now going to get, oh, and this is multiplied by dy dx. So now we get dy dx is y cubed minus x cubed divided by y cubed minus 3x squared. And so when that's the derivative, so if we set that equal to 0, then that implies that x cubed is y cubed, or in our case, x is going to equal y. So therefore, if x equals y, we want to plug that back to our original equation. So we get x to the fourth x equals y, so we're going to get another x to the fourth plus 2 is going to be 4. And again, we're going to get x, and then y cubed is going to be x cubed, so I'm going to get 4x to the fourth. So that's going to say that 2 is going to equal 2x squared, x to the fourth. So that implies x to the fourth is equal to 1. And so therefore we get x is equal to positive or negative 1. So if x equals 1, y is equal to 1. And if x equals minus 1, y equals minus 1. And that is our solution. Okay. And the last problem, so that was problem 5, this is problem 6. We actually want to compute the second derivative. So our goal is to find y double prime. Okay, so we're given x cubed plus y cubed is equal to 1. So that's going to give us 3x squared plus 3y squared dy dx is equal to 0. So now we're going to get dy dx is going to equal minus x squared divided by y squared. So this is our first part of the problem. That gives us the first derivative. We need that. So now we want to take the derivative of this, and so now we need to use the product of the quotient rule. Okay, so when we use the quotient rule, we're now going to get that the second derivative, remember this is y prime, we use the short notation. So the second derivative is going to be the, let's take the minus out because we know we're going to get negative. So it's the bottom, which is y squared, times the derivative of the top, which is going to be 2x, minus the top, which is x squared, times the derivative of the bottom, which is 2y times y prime. And all of that is divided by y squared squared, or y to the fourth. So let's push this negative through and we get y prime. This is y double prime. Y double prime is equal to 2x squared y times y prime minus 2xy squared divided by y to the fourth. So now we need to substitute here this y prime. Here's y prime. It now needs to go in there. So now we're going to get y double prime is equal to 2x squared y, and y prime was minus x squared divided by y squared minus 2x y squared divided by y to the fourth. So now we get y double prime is minus 2 x to the fourth minus 2x y cubed over y to the fifth. So we can factor out a minus 2x, and that's going to leave us x cubed. And I believe I changed the sign here. Let me see. Yes, this was negative, that's correct. We'll go to negative. I factor out minus 2x, so therefore this becomes plus y cubed. And then this is all over y to the fifth. But guess what? X cubed plus y cubed, let's go back to the original problem. Haha, x cubed plus y cubed equal 1. So therefore this answer just becomes minus 2x over y to the fifth.